right, folks, welcome back to MSDOSX. Okay, how's my volume in the back? Can you guys hear me all right? Okay, cool. So today we're going to finish covering the basics of Objective-C and kind of just fill in some of the pieces that we didn't cover last week. I'm going to start, though, before I actually get started, I wanted to talk about enrollment. Michael David said that he moved most of the people I asked out of the wait list. How many people are still on the wait list? Okay, so not very many. That's fine. My plan was to at some point have everybody sign in saying that they were here today, and I'll just make sure that everybody that's actually here will get added into the class. So I'll talk about that after the end of the lecture. I feel like I had something else I wanted to bring up, but maybe I'll remember by the end. Okay, so we're going to start by just a quick review of the message syntax in Objective-C, because I found that that's what people tend to struggle with the most, so making sure that you guys really understand how you define a message and how you call a message is kind of important. So here's an example of a method with no arguments. Again, we declare it with the minus sign indicating that it's an instance method. The inside parentheses, we have the return type, which in this case is an int, and then the name of the message. And then within curly braces is the body of this function, method, however it works. And then to call this method, you first, after the left square bracket, you have the object that's going to receive the message, followed by space, and then the name of the message. So this should be pretty straightforward, right? That's a no-argument method. This looks pretty normal. Here's a one-argument method. Again, we have the minus sign indicating that's an instance method, the return type in parentheses. And now the name of the message here includes a colon to indicate that we're passing in an argument, in this case another integer. And the way we call the method is, again, we start with the left bracket, we have the receiver of the message, followed by a space, the name of the message, then the colon, indicating that the next thing is going to be a parameter, and we pass in a number 3 here. Is this clear? Okay. And then the one that looks really weird to most people is multiple arguments. So again, we pseudo-name the arguments. We have movex and y is the name of this method. And when we call it, we separate the arguments across the method names. And I'm going to do a really short thing. I'm going to show you why this is really useful. So let me. Wow, I have a lot of spaces all of a sudden. And I should have had Xcode running. So I want to show you there's this method with this obscenely long name that if you tried to remember where all the parameters were without having these pseudo name parameters, you would never remember. So let me open up the documentation browser, which is probably going to run really slow because for some reason it searches really slow. NS bitmap image rep. So this is a class used to create bitmap representations, which is useful if you need to write an image out to files. You need to create a representation for that image.
Oh my god. Did you constrain it?
No, I haven't constrained it yet. That's probably why it's taking so long.
I'll show you that. You constrain which documentation is searched here. And so it looked like JavaScript is on like iOS 4.1, 4.2, and 4.0.
Okay, why is it not finding it?
Yeah.
Okay, better idea. Well, just you're going to laugh at how long this method is, but I just want to show it to you to prove why having these pseudo-name parameters is useful. Init with bitmap data planes, pixels wide, pixels high, bits per sample, samples per pixel, has alpha, is planar, color space name, bitmap format, bytes per row, bytes per pixel. Now, if that just had a name and then a parenthesized list of arguments, could you tell me which argument was which? I don't think so. I certainly couldn't. But since the parameters are all pseudo-named, and it's immediately clear when you start to call the method, and Xcode is really great at auto-completing for you. It'll just give you the slots for what arguments need to go where, and you know immediately what argument has to be what. So hopefully this is a sort of extreme example of why this naming convention of methods is really useful. the first time I saw this, I thought, there's no way in heck I'm ever going to use this. And this summer I discovered a use for it.
Yeah, I actually use it too. Use it this summer too.
Okay, I don't know why you... Okay, so do we have, before I move on, do any of you have questions about calling methods in Objective-C? Yes.
So
And what's your name? I want to learn names this semester, so if I call on you, I'm going to ask for your name.
Michael?
Michael, okay.
So if I wanted, like, for that example, can I do, like, turtle and y first, or do I...
No, the order is important. The name of the method is move x and y in that order. So, good question. Any other questions about method syntax? Okay, cool. So let's talk about some new things today. The first concept I want to talk about is the idea of a selector, and this is Objective-C's representation of the name of a method in some sense. They're objects, although I'm going to use that word in quotes because it's not an Objective-C object, it's just a thing that identifies the name of a method. It's not, for example, a method implementation, it's not a function pointer like in C. It is basically a string, although the compiler will actually compile it down to some integer value for efficiency reasons. I know I mentioned in the last lecture that Objective-C basically passes the string around to the method. It's not quite that, because that's kind of inefficient, passing around potentially a 100-byte wide character array. It'll compile them down into an integer. The type is SEL, which is a new Objective-C type. And as we'll see in a couple slides, this is really useful to enable polymorphism and dynamic binding. Okay, so there's a compiler directive at selector that allows you to make compiled selectors. So like I said, under the hood, these selectors are basically just an integer value I'm guessing it's just some sort of a hash on the string. I'm not sure quite how it actually does it, but it's something like that anyway. And these are great because at compile time, the name of the selector is compiled, and then you can just pass it around, and you can call the selector on really any object, which is kind of neat. It's not bound to any particular object or class even. It's just the representation of a method with a particular name. And in the case of parameterized methods, that includes the colons, which tells you that there are parameters in a certain spot. So here's a really simple example of I'm creating a selector for some method whose name is set with height, with the colons indicating the arguments. So I'm assigning this to a cell variable. And again, we see the @ sign, which again, it just means it's a compiler directive. Okay, so here's what's kind of cool and weird about selectors. The selector set with height identifies all of these methods and a lot more. It doesn't care if it's a class method or an instance method. It doesn't care what the return type is. It doesn't care what the parameter types are. It just knows that the I'll say signature, but that's a little bit of a bit not quite the right term. But the name of the message is what's fixed. So all of these, the name of the message is set with height, set with height, set with height. But you can see that it identifies a bunch of different methods, which is kind of neat because it allows you to call similar looking methods on different objects. You can also create selectors dynamically at runtime using a C function and a selector from string. Caveat there is it's not particularly efficient, so you shouldn't rely on this. But you can do it. Sometimes you can't determine what selector you're going to call at compile time, so this is one way to get around that. So my question, what's your name?
Yeah, Rishi.
Rishi.
I got confused. A selector allows you to choose all the methods that have that.
Yeah, and I'll show you in a couple slides of how to actually use a selector. But the idea is that this selector in some sense will match any of these methods.
So it's a signature without the types. I mean, the types are dynamic and bound at runtime, as opposed to being bound at compile time.
Okay, so suppose we have some string. We want to create a selector out of it. You just call NSSelector from string on it, and you'll get a cell for that string. Conversely, there is a function NSString from selector, which will take a selector and return the string representation of it. Not as useful, but you can do it if you want. Again, probably not super efficient because it has to unhash the value. Okay, so here's a really roundabout way of why selectors are useful. So we'll create a selector called quack selector that selects a message called quack. And then we'll take Donald Duck and perform selector quack selector, which is the same thing as calling quack on Donald Duck, which seems, I'm sure, like a stupid way to do this. But suppose we don't know that Donald Duck is a duck. We just know it's some object. We can perform quack on it, even though the compiler would, if we tried to just say quack on some object, the compiler would say, hey, this object probably doesn't respond to quack. But we can, if with perform selector, we can perform that. We can call that function, that method anyway. So here's another example of with the same thing, but with a parameter. There's another method on this object called perform selector with object that takes in a selector and an object to pass in. I believe there's also perform selector with object and another object. Beyond that, it doesn't have any. It only has up to 2. It's rare that you need this for more than 2 argument methods, because most methods you write probably have 1 or 2 parameters anyway. The way if you ever come across this situation, the way around that would be to bundle the arguments up in some data structure. But again, these two are equivalent. So you're probably wondering why this is even useful. There's this word again, polymorphism, that allows us to do dynamic method dispatch. And this is an example that I lovingly ripped from Apple documentation, where suppose we dynamically generate some object and dynamically generate some selector. And we don't know at compile time what method's going to get called, let alone what object we're going to call it on, but yet we can still do it.
I've used these before with finite state machines. It's really, really nice to be able to store state and action and store all the selectors in the action, and then just basically call the selectors as I change states directly, rather than having to look them up in a table or hold a bunch of objects that have specific types of selectors or specific types of methods. Just being able to store these selectors is actually a pretty powerful thing.
A more common use of this is what's called the target action pattern, which we'll see a lot more once we start getting into designing user interfaces on iPhone and Mac. But the idea is you have some control objects in your interface, be it maybe a button or a list view or a pop-up menu, and that object needs to somehow tell your code, hey, something happened, you should respond to this input. So how might we think about doing that? Well, the C++ approach would be something, just bind that to some function, just bind that to some method, and every time that event happens, it just calls that method immediately. The Objective-C approach is, again, more dynamic. It allows us to they send a message, and there's so we specify a selector that's just of the message we want to send, and then the target to whom we want to send it. So the idea is, we have a button. We want to listen for when that button gets pressed. We have some controller object that's managing our app that, when this button gets pressed, maybe presents an alert saying hello or something. So we can have our controller have some method that gets called every time that button gets pressed that will do the code to present this alert. And we just say that object is the target of this button, and the action it sends is the selector of the method we want. Does that make sense? Does anybody have any questions about target action?
You'll get some practice with that in the labs too.
I don't think we'll do it in today's lab, but in next couple labs we'll start to see that. So here's an example of target action. We have some button that presumably this is in some controller